Hi students, good morning. Welcome to this video session. My name is Samuel Dominic Chukwu Emeka, aka Sam Dom for Peace. In this video session, we shall discuss your section 3.4 assignment. Section 3.4 deals with measures of position. And this includes z-scores, box plots, quantiles. The quantiles includes the percentiles, the quintiles, the deciles, the percentiles, quintiles, deciles, and quartiles. But specifically, we shall just deal with the percentiles and quartiles. Then we shall also talk about the 5-number summary of data. So these are all what we call the measures of position or measures of location. The chapter in your textbook calls it measures of relative standing and boxplots, but they are all measures of position or measures of location. It is highly recommended that you read the notes. And view the videos on these topics prior to viewing this video. And you read the notes, you view the videos on the topics, then you can view this video, and then you can attempt your homework assignment. That way you will have a better understanding. As usual, the technologies we shall use in this video are my calculator and the Pearson Statcrunch. So with this video, we are only going to use technology. We are just dealing with technology. So I'm going to open up my website. I will use the mobile-friendly site. So you can type my name. Actually, if you type my name, Samuel Chukwu Emeka, the first site is my site. I am working on making this a mobile-friendly site. But this is my first website, the main website. And this is the mobile-friendly site, the AppSpot, chukwuemeka-samuel.appspot.com. So you can click on it. And you go to mathematics, statistics, and under the notes, you will look at z-scores, quantiles, and box plots. You will need to look at these notes. And for the videos, you also view it, quantiles and box plots. But you click on resources, and we are going to use Descriptive Statistics Calculator. So we're going to use this and then Statcrunch. I'm going to minimize this, so it could be on the same window. And actually, before I minimize, well, yeah, I'll just leave it like this. So let's begin. Question 1. If your score on your next statistics test is converted to a z-score, which of these z-scores would you prefer? The z-score that you would want to prefer is the highest one, z equal to 2.00. When we talked about z-scores, we say it can be used to compare scores on the same scale or even scores on different scales, you want the highest z-score because it corresponds to the highest of the 5 different possible test scores. Okay, the highest one. So I would go with z-score of 2.00, and that is option C. Question 2. With a height of 68 inches, Marvin was the shortest president of a particular club in the past century. The club presidents of the past century have a mean height of 74.4 inches and a standard deviation of 1.6 inches. A, what is the positive difference between Marvin's height and the mean? So I'm going to come here, let's expand this, and I'm going to look at the measures of position. I'll click here, measures of position. And this is the one that I will use. This is the calculator that I will use here. Some questions we are going to use my calculator, and some questions we shall use Statcrunch. Okay, we are going to look at those questions. There are some questions that Statcrunch will not do, but my calculator will do it. And there are some questions that my calculator will not do, but Statcrunch will do it. So, and there are so many calculations that both calculators can do. Okay, so I'm gonna, for this question, I will just use this. The data value is 68 inches. The mean is 74.4 inches. The standard deviation is 1.6. And you press calculate. So it says here the positive difference between Marvin's height and the mean. So they are just looking for the positive difference. Okay, so just like the absolute value of this difference. So I'm just gonna put 6.4. Then the difference is how many standard deviations. It is a negative. Well, since we are looking for the positive difference, also just do 6.4 divided by 1.6. And that is 4 standard deviations. Okay. The z-score is a negative 4.00. We always want to round z-scores to 2 decimal places. That is the standard. Although here it says type an integer or decimal, rounded to 2 decimal places as needed. We've talked about as needed before. So in this case, if you write -4, that is fine. If you write negative 4.00, that is still fine. Okay. Is Marvin's height usual or unusual? It is unusual. Question 3. A particular group of men have heights with a mean of 175 centimeters and a standard deviation of 6 centimeters. Charlie had a height of 195 centimeters. So I'm still going to use this calculator. I can click reset here. If you want to remove this, you just refresh your browser. But otherwise, you can leave it. In this case, the data value is 195. The mean is 175. The standard deviation is 6. And then you press calculate. So the positive difference is 20 centimeters. The difference is 2 decimal places. Is 3.33 standard deviations. The z-score is 3.33. And the data value is unusual. It is unusual. Question 4. IQ scores are measured with a test designed so that the mean is 114 and the standard deviation is 11. Consider the group of IQ scores that are unusual. What are the z-scores that separate the unusual IQ scores from those that are usual? What are the IQ scores that separate the unusual IQ scores from those that are usual? Consider a value to be unusual if its z-score is less than -2 or greater than 2. Yeah, we talked about this when we discussed z-scores. So for the z-scores, the lower boundary, of course, is -2, and the higher upper boundary is 2. Now for the IQ scores, I'm just going to use this section of the calculator. The mean is 114 and the standard deviation is 11. Enter. So the lower IQ score boundary is 92. The upper IQ score boundary is 136. Okay. Question 5. In a recent year, the magnitudes on the Richter scale of 10,594 earthquakes were recorded. The mean is 1.249 and the standard deviation is 0.572. Consider the magnitudes that are unusual. Okay, what are the magnitudes that separate the unusual magnitudes from those that are usual? So I will still use this calculator here. The mean is 1.249. The standard deviation is 0.572. And you press calculate. So the lower boundary is the lower boundary, type an integer or decimal. So the lower boundary for the earthquake magnitude is 0.105. The upper boundary is 2.393. Question 6. One of the tallest living men has a height of 259 centimeters. One of the tallest living women is 243 centimeters tall. Heights of men have a mean of 178 and a standard deviation of 8 centimeters. Heights of men have a mean of 178 centimeters and a standard deviation of 8 centimeters. Heights of women have a mean of 163 centimeters and a standard deviation of 4 centimeters. Relative to the population of the same gender, who is taller? Explain. So let us see which one has the higher z-score. Okay, let's find the z-score for the man, for that particular z-score for the man that has this height, and then z-score for the woman that has this height. Then we can see, is it the man or woman that is taller? So we're gonna use this here. I'm gonna reset this. The z-scores are what we shall be looking at. Okay. So the person that has the higher z-score is the one that is relatively taller. For the man, the height is 259. The mean of the heights of men is 178. So he's very tall. The standard deviation is 8. Okay. So the z-score is 10.125. That is for the man. So you can write it on your paper, 10.125. Although really, you know, these videos that I do with technology is paperless. Because we are just using technology. I mean, we have solved it, you know, by hand. That's on paper, by hand. But all these videos that I do, that I call study guides, that I do with technology, is kind of paperless because the technology does it. Okay, so just note this is 10.125. Just note that. Let's do the woman. For the woman is 243 tall, 243 centimeters tall. Mean height of women is 163, and the standard deviation for the height is 4. Calculate. Wow, the z-score is 20. That's much bigger. So the woman is taller. The woman is taller because the z-score for her height is greater than the z-score for the man's height. Okay, so of course you eliminate options C and D. You look at A and B, you will see that the z-score for her height is greater than the z-score for the man's height. So the option is A. Question 7. Which is relatively better? A score of 76 on a psychology test or a score of 39 on an economics test? So we discussed this when we did z-scores. Scores on the psychology test have a mean of 88 and a standard deviation of 12. Scores on the economics test have a mean of 50 and a standard deviation of 5. We are going to still use this calculator. So let us get the one for the psychology. The score is 76. The mean of the scores is 88. And the standard deviation of the scores is 12. Enter. So here the z-score is -1. Okay, just take note of that. Then for the economics, the score is 39. The mean of the scores is 50. And the standard deviation is 5. Enter. So for the psychology, the z-score is -1. For the economics, the z-score is -2.2. -1 and -2.2, which one is greater? We say it's -1. So that means that the psychology test score is better. Okay? Because its z-score is greater than the z-score for the economics. Okay? So that would be option D. Option D. Question 8. Below are 36 sorted ages of an acting award winner. Find the percentile corresponding to age 66 using the method presented in the textbook. All right, so in this case, we're going to use Statcrunch. We will click right here on this icon, click on it, and click Open in Statcrunch. I like to name my variables. If you don't want to name it, that's fine. But I like to name it, so I'm just gonna put ages here. The percentile of the value 66. Before we find it, we have to sort the data. We have to arrange the data in ascending order. We do it in ascending order because you start from the kindergarten to the first grade, to the second grade, to the third grade. Ascending order. We prefer ascending order, very important. And from the definition of what percentile is, to find the percentile of value 66, you need to find all those, how many scores are, how many ages are less than 66, how many uh, winners have scores less than 66. Then if you find how many of them there are, and then you divide it by the total number of ages, and you multiply by 100. So for us to do that, we have to arrange the data in ascending order. Statcrunch says sort. We use sort here. So what I'm gonna do is I will go to data because well, I think it's arranged already. With this, it's arranged. So it's already arranged. So that is great. If we look at this, it's arranged. Okay. So we'll just use it this way. We did an example of sorting data, arranging the data in section 3.2. We did that. Okay, so we will just find, in this case, the sample size is 36 ages. It's already sorted, that's true. Look at it right here, it says it here, 36 sorted ages. Okay, so let's find the data value 66 is right here. And how many ages are less than 66? 26 people. 26 people have ages below 66 years, right? 26 people. So we will do this 26 divided by 36 and then multiply by 100. That is how we calculate it. So I'm just gonna get this simple calculator that Mark has. I have a very simple calculator. Okay, so we can just do 2600. 26 times 100 is 2600. Then divided by 36. Okay, divided by 36. And we round it to the nearest integer. This is 72. Okay, the percentile is 72. I'll minimize this. Close this. Question 9. We do the same thing for question 9. Open in Statcrunch. It is already sorted. We see here is 10. 10 people are younger than 33 years. Okay. We are asked to find percentile of value 33. So 10 people are younger than 33 years. So 10 times 100 is 1,000. 1,000 divided by 36. 1,000 divided by 36. And that is 28. If we round to the nearest integer, that gives us 28. Okay. We can minimize this and we close this. Question 10, below are 36 sorted ages. Find the 30th percentile using the method presented in the textbook. So they are asking us for the 30th percentile. They are not asking us for percentile of a value. In this case, they're asking us for the 30th percentile. And we've discussed all this when we did quantiles and boxplots. Okay, we discussed this. So what we're gonna do is we open it in Statcrunch. We will use Statcrunch for this one. And the variable is ages, if you wish to name it. You just go to Start, Summary Stats, select Columns, and select the ages, the variable ages. And we are just looking for the 30th percentile. We don't really need all these. We don't need all these. So you don't really need to select any of these at all. But if you don't select any of these, it will all appear in the results. And we really don't want that. So let's just pick the sample size. Yeah, but we don't need this. This is what we need here. Percentiles. Enter 30 for 30th. So I'm just going to put 30. Okay. And we click compute. So the 30th percentile is 40. You just click you just put 40, and that is it. The next one, find the third quartile. Find the third quartile. Okay. The third quartile is your 75th percentile. Remember, we discussed this in quantiles and boxplots. So we'll just click here to open this, open in Statcrunch. You go to Stats, Summary Stats, Columns, select the variable 1, okay. They just set values, so it's good. I mean, we can just leave it variable 1. And we are looking for, we really don't need all these. Well, we need, we need this here because we have the third quartile. The third quartile is part of the 5-number summary. So we scroll down until we see Q3, okay, third quartile. And if you want to play with this, you can just put 75 here. You don't need to, but it's just to let you know that the third quartile is the 75th percentile, okay? It's the same thing. So that gives us 64. Question 12, 50th percentile. The 50th percentile is your median. You can also do this with my calculator, but that is a lot of, I mean, it's 36 ages. So let's do it with Statcrunch. 50th percentile. So I open it in Statcrunch. These are also ages, if you wish to name it. Go to Start, Summary Stats, Columns, select ages, and we're just looking for the median. Okay. If you want to, you can also type 50 here. It gives you the same thing. You click compute. So the 50th percentile is your median, and that is 38.5. Okay. The next one is the 75th percentile. Your 75th percentile is your third quartile. So we go to open a Statcrunch. This is ages. Start, Summary Stats, Columns, select it. 75th percentile, which is your third quartile. So if you can just put Q3 here. Or if you want, you can also type 75 here. Doesn't matter. So this gives us 66.5. The next question is asking us for the 5-number summary of data. The following are the duration times in minutes of all missions flown by a space shuttle. Use the given data to construct a box plot and identify the 5-number summary of the data. So we'll open this with Statcrunch, open a Statcrunch. And these are duration times, and I've just put times. And if you want, you can also put minutes. Just don't put space between the variables. It's advised. Okay, so You can also leave it like that, var1. It doesn't matter. And even if you put space, that's fine. It will not affect the results. But it's better not to. You see how all these variables are just written var2. They didn't put any space. Okay, so let's find the 5-number summary of data. We click on Start, Summary Stats, Columns, select the variable, times. Now the 5-number summary of data, the first one is the minimum. Then you will hold if you're using Windows, you put your finger on hold the Shift key. If you're using Mac, hold the Command key. If you're using Mac, I'm using Mac right now, so I will hold the Command key to make multiple selections. So the 5-number summary of data, the first one is minimum, then the first quartile, which is Q1, then the median, which is Q2, or the second quartile, then the third quartile, and then the maximum. This is the 5-number summary of data. And you just click compute. Okay? So this gives us 8630. They say use ascending order, round to the nearest whole number as needed. So the median, the value of the median is not a whole number. We will round it to the nearest whole number. That gives us 10015. Then the third quartile is 11431. And the maximum is 11875. Enter. Choose the correct box plot of the data below. So I'm just going to close this particular result here. Actually, with boxplot, it gives us the whole thing again. So we go to graph, we go to boxplot, we select the columns, and you want to check this box, draw boxes horizontally, because these boxes are drawn horizontally. So you want to check this box. If we wanted to identify outliers, which we don't need to, we will also check this box. Otherwise, you just check the box, draw boxes horizontally. And you can just leave the rest as is and press compute. So with if you point your mouse at this, you'll see the 5-number summary of data as well. Okay, minimum, first quartile, median, median or second quartile, then third quartile, and the maximum. So we could have just done this as well, but I wanted to show you the other way. All right, so let's start by elimination. Who we are going to eliminate. You can always maximize, expand this to see it clearly. You can always do that by clicking this expand button, the plus button, the plus icon, this to see it clearly. But I can see this clearly right now. I'm gonna start by elimination. Let's start with the minimum. If you point your mouse here, the minimum is 5. Okay. This is from 0 to 12,000. The minimum is 5. Here is 6,000. We eliminate A. Here it is 0. We eliminate B right away. We really want to look at it very well so that we don't make mistake. So we eliminate A. Now for B, it's not in 0. So let's leave B. Let's kind of leave B. We just eliminate A, but we leave B, C, and D. Okay, let's check the maximum. The maximum is 11,875. So we look for which one we can eliminate based on that. If we look at C, the maximum seems to be 11,875. We leave it. We look at B, seems to be that. We leave it. We look at D, seems to be that. We leave it. Okay, let's look at the median. Let's look at the median. The median is 10,015 approximately. 10,015 approximately. Let's look at the C. The median 10,000, because this is 6,000, 7,000, 8,000, 9,000, 10,000, 11,000. So C is okay. Let's leave it. Let's look at B. 7, 8, 9, 10. B seems okay for the median. Let's leave it. We look at D. 7, 8, 9, 10. Okay, we eliminate D because this is a 7, 8, 9, 10. And this is in between 9 and 10. So we eliminate D. So we are concerned with B and C. Okay. Let's look at the first quartile. First quartile is 8630. 8630. So let's look at B. First quartile 8630. 7, 8. Okay, let's leave it. Let's look at C. First quartile 8630. Okay, this is not it. The first quartile here is about close to 7, but it should be more than 7. It should be actually more than 8. So B becomes the correct option. Okay, so you have to be doing like, that's the way it's easier to find out. Okay. I'm gonna close this. Next question, question 15. The following are the interval times in minutes between eruptions of a geyser. Determine the 5-number summary and construct a box plot for the data below. So I will just open this data in Statcrunch. And let me just construct a box plot right away because it gives me that. If I want, I can put this times and just put it. I can name the variable. I go to graph, box plot. Select this. Draw boxes horizontally. Compute. So the minimum is 81. Then the type integers or decimals. Okay. 81, 87.5, 92.5, 98, 109. Okay. 81, 87.5, 92.5, 98, 109. Okay, let's make sure. All right. And you can press enter. Okay. Now let me start with the process of elimination. Minimum is 81. A is okay for now. B is no. Well, B is no. Okay, because this is 85. Look at B here. This is 2. I know this minimum here is after 85. Okay, because this is 80, 85, 90, 95, 100. So this minimum here is more than 85. So we eliminate B. C is okay and D is okay. Now let's look at the maximum. The maximum is 109. A is okay for now. C is okay, and D is okay for the maximum. Then let's look at the median. The median is 92.5. 92.5. This looks like 90. This looks like 90, but let's leave A as okay. Let's look at C. 92.5. This is okay. C is okay. Let's look at D. 92.5. D is okay. Okay. Now let's go to the first quartile is 87.5. 87.5. Yeah, this looks like actually 90, not 92.5 for this median here. So let's eliminate A. Let's just deal with C and D. So the first quartile, 87.5. C is okay. And D is okay. Now let's look at the third quartile, which is 98. 98 here. This is 90, this is 95. So the third quartile here is before 95. No. So C is not okay. Okay, let's look at D. Yeah, D is okay. So we now put D. Okay. The next one, question 16. The following are amounts of time in minutes spent on hygiene and grooming in the morning by survey respondents. Determine the 5-number summary and construct a box plot for the data given below. So I prefer using, let's open this in Statcrunch. And I'm just gonna use and then this as times. I will just find this normal way for the 5-number summary. So we have the minimum. You hold the the shift key or the command key to make multiple selections. So we have the minimum, the first quartile, then the median, then the third quartile, and then the maximum. Compute. So I have here 5, 17, 19, 35, and 62. Now the box plot. I close this, go to graph, select box plot, select the columns, check the box, draw boxes horizontally, and then click compute. All right, let's start with elimination. Actually, if you look at this visually, okay, we eliminate A. Like, let's look at this visually. A is eliminated right away. Right away. D is eliminated right away. A and D are gone right away. So we should be focused on B and C. So let's look at B. If we look at B and C, minimum is 5, B is okay, and C is okay. Maximum is 62. Maximum is 62. So B is not okay. B is not okay for 62. Okay, let's look at C. Yeah, C is okay. So so I will just say C. Okay, I'll just say C because you eliminate the rest, and C is the only one that is correct. Question 17. The following are speeds in miles per hour of cars measured with a radar gun. Determine the 5-number summary and box plot for the data given below. So let us open this in Statcrunch. And these are speeds. So we go to Start, Summary Stats, Columns, select speeds, mean, first quartile, minimum. Please, if I say mean, I don't mean the MEAN. I mean MIN, minimum, first quartile, second quartile or the median, third quartile. Okay, I've made mistake here, so I'll just start again. Minimum, first quartile, median or second quartile, third quartile, and the maximum. Compute. So the 5-number summary of data will be 70, 71, 74, 78, and then 79. Enter. What is the correct box plot? Graph, box plot, speeds, draw boxes horizontally, compute. So, if we look at this, we kind of, I don't want to jump and say it's D. No. Okay. I don't want to jump and say it's D visually. No. I don't want to do that. So let's just do it. I know it's not going to be C. C is eliminated anyway. Excuse me. C is eliminated just by visually. You look at this visually, C is out. Now let's do the rest. Minimum is 70. So A is okay, B is okay, D is okay. Maximum is 79. A is okay, B is okay, D is okay. Median is 74. Median is 74, the middle guy here. And that eliminates A, okay? Because this here is 73. So A and C, gone. And let's look at B and D. Okay, B is okay. D, the median is 74. Yeah, D is gone. So that leaves us with only B, okay? Question 18. Use the same scales to construct box plots for the pulse rates of males and females from the accompanying data sets. Use the box plots to compare the two data sets. So let's go ahead and draw the box plot. We click on this icon, then we click here, open in Statcrunch. So I'm just gonna close this right here. We go to graph, we select box plot. Let's do the one for the men's first. So I'm gonna put men's, draw boxes horizontally, and then compute. Okay. So by just visually looking at this, B is eliminated. But let's look at the rest. Minimum is 48. Minimum is 48. And by that, A is eliminated. A is gone. A is eliminated. So, of course, B is also eliminated right away because the minimum is not 48. C, minimum is 48. C is okay. D is okay. Now the maximum is 92. So C 92, C is okay. D is okay, 92. The median is 67. This is more than 67, so C is not okay. C is not okay. D is okay. So the answer will be D. Okay. Now let's do that of the women. I go to graph, box plot, women. You select women, women's pulse rates. Then check the box, draw boxes horizontally, compute. Minimum is 58. A is eliminated. Okay, A is out. 58. B is okay. Minimum of 58. C is okay. D is okay. All right. Maximum is 104. B is okay because this is 100 and this is 105. B is okay. C is okay. D is okay. Median is 76. Median is 76. B, let's say B is okay for now. Looks like, well, looks close to 80. Okay, B is okay. 76. C is out because the median here is less than 75. So C is out. Then D is okay. Let's see. First quartile is 70.5. Okay, B is okay. D is okay. Third quartile is 83. 83. This is more than 85. Okay. So B is out. That leaves us with D. But let's check D also. 83. Yeah, D is okay. Okay. All right. Compare the two box plots. Choose the correct answer. It's good when you're doing this. Looks like the first of all says, in general, it appears that males have lower pulse rates than females. So let's compare the two box plots. Let's do the two on the same scale. So go to graph, click on box plot, and select both of them. You hold the command key, select the women's pulse rates, so check the box, draw boxes horizontally, click compute. I would like for men to come on top first before the women, so I can look at them. So let me do this way. Graph, box plot. I will select women first, women's pulse rates first, then the men's pulse rates. Draw boxes horizontally, compute. There you go. I think men to come first. So if you look at this here, if you look at the men, the minimum is 48 for the men. Minimum here is 58 for the women. Maximum is 92 for the men. Maximum is 104 for the women. So Q1 is 60 here. Q1 is 70.5. So it looks like the men have lower pulse rates generally. Median is 67 for the men. Median is 76 for the women. So males have lower pulse rates. They have lower pulse rates. Okay, they have lower pulse rates. This other option says higher pulse rates. B is eliminated. Okay, so C is okay. D is eliminated. So let's look at A and C. Now the next one, the variation among the male pulse rates is much greater than the variation among the female pulse rates. The variation, when we talk about variation, variability, we talk about the range, the variance, the standard deviation. The easiest one we can use in this case is the range. So let's look at the range. If you do 92 minus 48 for the men here, the range, that gives us 80. 12 minus 8. 12 minus 4 is 8, and 8 minus 1 is 7. 78. Okay, 78 is the range for the men's pulse rates. And for the women is, let me make sure I calculated, because I don't want the IQR is interquartile range. So for the range for the men's pulse rates is 78. Oh no, I'm sorry. I'm looking at the IQR. Oh, please don't be mistaken, okay? The interquartile range, no. Look at the minimum, which is 48. So for the men's pulse rates, the minimum is 48, the maximum is 92. So the range is 12 minus 8 is 4, and then 8 minus 4 is 4. So 44. Okay, 44 is the range for the men's pulse rates. For the women's pulse rates, 14 minus 8 is 6, and 9 minus 5 is 4, is 46. So we can say that the variation, 44 is less than 46. So we can say that the variation among the male's pulse rates is much greater. No, it's not. So we'll go with C, that is similar to the variation among the females' pulse rates. Okay, C. All right, question 19. Use the same scale to construct box plots for the ages of the best actors and best actresses from the accompanying data sets. Use the box plots to compare the two data sets. So we'll click here, open in Statcrunch. I'm gonna close this. Let's do for the actors data. Go to graph, boxplot, actors data, actors age data. Draw boxes horizontally. All right. Let's compare. Minimum is 29. A is okay. B is okay. C is okay. D is okay. All right. Maximum is 76. A is okay. B is okay. C is eliminated. Look at C here. Maximum 76. So C is gone. D is okay. D is okay. The median is 42. A is okay. Median is 42. B is gone. Okay, because here it is greater than 45. So B and C are gone. Then D, median is 42. Okay, D is okay. Right? We're looking at now A and D. The first quartile is 38. First quartile is 38. A is okay. D is okay. The third quartile is 50. Third quartile is 50. A is okay. But D is not. D is more than 55. So the correct option would be A. Okay. Let's do for the actresses. I'll click graph, box plot, actresses, draw boxes horizontally, compute. So here, minimum is 23. A is okay, B is okay, C is okay, D is okay. Maximum is 79. A is okay, B is okay, C is okay, D is gone, D is out. Maximum is 79. Okay, this is less than 60. So we are left with A, B, and C. All right, the median is 34. Median is 34. A is okay. B is not. B is more than about 45 or more than that. So B is out. B and D are out. 34. C is out. Okay. Median is 34. C is out. Also. C is out. Okay, because this is 35. It's more than 35. So A is the option that we are left with. All right. Compare the two box plots. Choose the correct answer below. Let us construct the two box plots on the same scale. Go to graph, box plot, select the two, draw boxes horizontally, compute. So it says here, although actors include the oldest age, the box plot representing actors shows that they have ages that are generally lower than those of actresses. We look at this. Let's look at this. For actors, the minimum is 29. Actresses, minimum is 23. Maximum is 76 for the actors. Maximum is 79 for the actresses. Q1 is 38 for actors. Q2 is 28.5 actresses. Median is 42. Median is 34. So A is not, no. The actors do not have ages lower than actresses. No, that's not true. Generally lower, no. No. B, although actresses include the oldest age, the box plot representing actresses shows that they have ages that are generally higher than the actors. That's not true. C, although actresses include the oldest age, the box plot representing actresses shows that they have ages that are generally lower than the actors. Yes, that's true. The only age that is greater, is the highest, is maximum for 79, and here maximum is 76. But the rest of it, 29, 38, 42, 50. And this is 23, 28.5, 34, 37.5. So this, yeah, C is, C is true. Although actors include the oldest age, the box plot representing actors show that they have ages that are generally higher than those of actresses. Yeah. I'll go with C. I'm gonna go with C. Okay. All right, question 20. When a data value is converted to a standardized scale representing the number of standard deviations, the data value lies from the mean. That is called a z-score or standard score. A data value is considered dash if its z-score is less than -2 or greater than 2. Is unusual. We did this in my notes and videos. Whenever a data value is less than the mean, the z-score will be negative. The z-score is going to be negative. A modified box plots, a data value is dash if it is above the third. This is the upper fence and this is the lower fence. So outliers, okay, outliers, outliers. Go to notes. If it is outliers, quantiles and box plots, is an outlier. We determine outliers using fences. So the upper fence is this and this is the lower fence. So an outlier, if it is above the upper fence, the data is an outlier. If it is above the upper fence and lower than the lower fence, below the lower fence or above the upper fence, that's an outlier. So this is the upper fence here. The third quartile plus 1.5 times the interquartile range. And this is the lower fence. The first quartile minus 1.5 times the interquartile range. So this is outlier. Outlier. Okay. Question 24. Which of the following is not a value in the 5-number summary? Of course, that's the mean. All right. We just saved this. Thank you so much for listening to this video session. Please feel free to ask questions if you have any. And you have a great day.